Hello, my name is Tammy Freeman and I'm an online editor at Physics World. Welcome to today's webinar, Comprehensive Machine Targeting and Image Quality QA with the QUASAR Penta-Guide system. Today's session, looking at Modus QA's Penta-Guide Phantom, will include an introduction to the new software application, Penta-Guide 2.0, which is available for free for every Penta-Guide customer. With me today, I have Rocco Flores, who is a product manager with Modus QA. Rocco will give us an overview of the Penta-Guide Phantom and its abilities, including a demonstration of the new software and user workflow. At the end of the presentation, we'll be running a Q&A session, so if you have any questions for Rocco, please do send them in at any time during the webinar. There are also 2 handouts that you can download from the webinar panel. So, Rocco, hello. To start with, could you provide an overview of the Penta-Guide Phantom for our attendees?
Absolutely, yes. Thank you everyone for attending today's session. For those of you that are unfamiliar with the Penta-Guide Phantom, it is the preferred third-party IGRT and SGRT QA Phantom. It was designed to fulfill the testing recommendations put forward by TG142 for machine targeting QA. We do have over 4,000 Penta-Guides in use around the world, and it has been serving physicists for over 14 years in over 100 countries. So it is by far Modus's most popular Phantom with a high level of versatility as well as clinical uses.
Can you provide a description of how the Phantom has been traditionally used within the radiation therapy department?
Yeah, the Penta-Guide has commonly been used as a comprehensive QA tool, covering those recommendations from TG142 for linac IGRT targeting. So to highlight the testing capabilities, you can verify your laser to isocenter coincidence, light field to beam isocenter coincidence, field geometry accuracy, optical distance indicator accuracy, gantry and collimator alignment, 2D and 3D imaging capabilities, which includes KV-KV, KV-MV, DRR, and CBCT isocenter coincidence. You can verify the correlation between your CT SIM imaging system as well as your linac imaging system. And you can also verify your linac remote couch adjustment accuracy during image matching, as well as patient positioning. Now, there are some clinics that are using more simple devices for routine daily QA and only use the Penta-Guide periodically for more robust testing or for more advanced systems offering SRS or SBRT techniques. But today I will introduce some new features that will hopefully convince those users to apply the Penta-Guide to their daily QA program. Another traditional use of the Penta-Guide is testing 6-degree of freedom couch adjustments. So, with the addition of our optional Penta-Guide tilt plate, you can now add intuitive testing ability for a relatively complex problem. So the tilt plate itself has embedded angles of 0.75, 1, and 1.25 degrees into the surface where the Penta-Guide sits. So it also has guidelines for your initial laser positions to provide you known translations from multiple directions. And you can simply alter the position and rotations by using a different starting location or by simply rotating the setup by 90 or 180 degrees. So by obtaining a cone beam of the setup, you can perform a 3D image match of the Phantom, apply those translations and rotations with your 6-degree of freedom couch, and then you can verify that those adjustments were performed as expected. As part of the traditional uses of the Phantom, physicists really like the intuitive visual features that we've included in the Penta-Guide. So with a quick glance, you can easily determine if the parameter is in or out of tolerance. So as you can see on this image here, we have physical landmarks indicating pass-fail criteria. So the corners as well as the field borders have 1 millimeter and 2 millimeter channels that are inscribed to indicate where your light field is falling if it is out of tolerance. And the isocenter itself has 1 millimeter target circles that indicate the amount of discrepancy you're finding in your laser alignment. So in addition to those exterior features, the internal design of the Phantom provides intuitive imaging assessment as well. As you can see in the animation on the right side, the Penta-Guide houses 5 hollow spheres in an offset pattern. And there are 2 reasons for this. Being low density, the spheres do not introduce significant imaging artifacts, which provides clearer images, therefore making it easier to image match and analyze the data. And the second reason is that the alignment of the spheres matches the ring structure that is embedded into the exterior surface of the Phantom. So you can imagine a projection image coming from a lateral or vertical projection. the alignment of these objects would be useful to verify the alignment of your system. So I can bring your attention to the image on the left side. The AP image here shows the geometry in perfect alignment, where the spheres are perfectly aligned within the rings. And so the images on the right side of the screen show you visuals where there may be a misalignment. So a translational misalignment can appear at the edges of the Phantom. When you use a 16 by 16 centimeter field, it will not have symmetric edges if it's out of alignment. And in the example below here, this will show you an example of when there's a misalignment of the gantry, which can be revealed where the sphere does not align perfectly within the ring. So please keep in mind that these are visual aids to be able to quickly and intuitively determine a pass-fail situation. We will review in a few moments how the software can provide quantitative information on your imaging alignment.
Okay, so Rocco, you've mentioned to me that the Penta-Guide has some newer functionalities that some of our audience might not be aware of. Could you share these now?
Yeah, for sure. This may be news to some of you attending the session, but a very popular use of the Penta-Guide is verifying the alignment capabilities of surface-guided radiation therapy systems. So the Penta-Guide is supplied by some major SGRT equipment manufacturers as the preferred tool to QA their system. So the larger surface of the Phantom is easily detected by the SGRT optical system, and the included features provide the intuitive pass-fail determination. So in essence, the SGRT system will image the Penta-Guide Phantom and place it at the isocenter using the remote couch adjustments. And then that alignment accuracy can be verified with the IGRT system by performing a cone beam CT. And then the isocenter and then the treatment isocenter can be verified using MV projection images. If you add the use of a tilt plate, you can now alter the rotations of the Penta-Guide and perform the 6 degree of freedom couch adjustments using the SGRT system. So overall, you now have a Phantom that can complete the entire isocenter alignment QA for SGRT, IGRT, as well as the treatment delivery isocenter. And an exciting new option that we have recently introduced is the free Penta-Guide 2.0 software. The design features of the Penta-Guide have allowed us to unlock a series of testing abilities designed to add value to the end user. The added functionality includes image quality metrics trending and reduces the need of additionally scanning an image quality phantom such as the CAT fan. So as you can see on the image here, we have added the ability to automatically analyze and trend geometric distortion, Hounsfield unit constancy, uniformity, spatial resolution, linearity, as well as noise. So for geometric distortion, we compare the CBCT imaged internal geometry to the known dimensions of the Phantom. And we also provide information on shifts in sphere positions, their size, phi angle, as well as scaling and voxel sizes. For Hounsfield unit constancy, we provide air and acrylic density values to perform an ongoing assessment that the values are in line with an established baseline. For uniformity, we compare pixel values at the center of the Phantom and compare them to multiple regions throughout the Phantom. Spatial resolution is determined by calculating the modulation transfer function. Linearity reports differences in alignment between superior and inferior spheres. And noise to contrast values determine the noise levels within the system. And again, we feel that these are important metrics to trend in order to verify that the ongoing health of a linac imaging system, especially with the advent of more adaptive therapy techniques.
Yeah, those new features sound really interesting. Could you explain how users can implement the Phantom and these features into their daily QA workflow?
Another important aspect we have implemented is an efficient workflow for morning QA. So having been a therapist for over 20 years, I understand the importance of getting QA done quickly in the morning in order to maximize your treatment time. So we've provided instructions on how to create a test patient of the Penta-Guide and also suggested scanning processes in order to complete your daily QA, in 15 to 20 minutes. So the machine alignment is verified and, you get valuable image quality metrics that can be captured. And this will give you a reason to scan this Phantom daily as opposed to once a week or once a month.
Okay, that sounds like a simple and efficient process to get started using. Could you maybe give a demonstration of the actual software for our listeners?
Sure, yeah, I'll bring up the application now. So this is the Penta-Guide 2.0 software. And I've just got the introductory screen here where it shows you information on how to actually complete step by step the tests that we have in our profiles. So on our workflow guide, which we can show you here, just click on the question mark button and it gives you the recommended workflow guide that I had actually just shown you on the screen. So this actually gives you step-by-step instructions as well, which, this comes with the Phantom. And again, just keep in mind that these are recommendations on how to provide efficient testing, but at the same time, get the required data sets you need for your imaging metrics analysis. So again, we have different profiles, so it gives you explanations on how to actually perform each test. So that's handy to have with the software. But I will focus a little bit of time on the single series view. So what this is, it's an area that gives you all those metrics that we've just explained. So focus your attention at the bottom of the screen. This is our data grid where you can import all your DICOM files. So you can simply click and drag them into the software, into this window, or you can just click on this add a file import feature. And as the data sets are brought into the software, it automatically determines what type of profile it is, whether it was an aligned cone beam, whether it was an MV, 6 degree of freedom test, and it puts it into a profile category. And reasoning for that is you can compare apples to apples when you're doing these trending views that I'm going to show you in a moment. So having said that, there are, sometimes people will try to do different tests that maybe the software doesn't recognize, like a different alignment for your own purposes. And so you can simply change the profile by just clicking on this button here at the top right side of the screen. So another thing I wanted to show you with this data grid is you notice there's yellow and green bars here. So anyone that's yellow is actually your first data set that you bring in of a certain type will be assigned as the baseline. Now your baseline, you're going to want it to be something that is a data set that you obtain after acceptance, or if there's a major hardware change, and that's where you want to start your comparisons from. So every future cone beam or every future MV image will be compared to that baseline. And so again, you can select your baseline if you want to change it by clicking on this button here. And you can use either a data set that comes from your linac, or you can actually choose the CT imaging set that came from your simulator if you choose to do that comparison. So I'll jump into now the actual metrics that we obtain. So up here at the top, you see there's a wide variety of categories that this covers. So it does pull information from the DICOM files, but it also does automated measurements on its own. So you can see here, it's giving you voxel sizes here with your geometry. So with your geometry, it's giving you your isocenter alignment information and all the locations and diameters of all the spheres that are within the Phantom. And you can see here you have your values, how it falls within in relation to the baseline measurement, and then it has what tolerance settings that you have here. And if it's highlighted in green, it means it's falling within your tolerances. If it highlights the feature in red, that means it's out of tolerance and would require some more investigation. So we also provide information on the roll, pitch, and yaw of the Phantom, and that way you can verify if those shifts were done correctly. We provide with image quality, we're giving you scaling error, means, and standard deviations, uniformity measurements, distortions within all the spheres that are located in the Phantom as well. We provide information on the phi angle, which if you can see this on your screen now, it just provides you the angle of all the spheres alignment. So if this is differing from day to day, there could be an issue with distortion. We get into some image quality metrics as well. So we do provide MTF for 50%, 20%, 10%. We're giving contrast to noise ratio information, non-collinearity, and CT numbers for ounce field unit constancy. So this is an important one. I'll just stop here for a second and show you. So we are providing two values. So we provide air and we provide acrylic, and it's not necessarily an electron density Phantom. However, you do have those two materials where you can now ensure that there's a constancy there where you're still falling on your curve that you established back at commissioning. So as I said, you can trend these features, and this is where the power lies in the software. So I'm going to click on trend, and you can trend any of those metrics that I've just spoken about. And what it does is it gives you this graph here, and it plots all of your results based on what their values are. And so it indicates what your tolerance is set, and it indicates what your results are. So you can use this as a tool where, as if your values are changing and they're becoming out of tolerance, this would spark you to do some further investigation as to what is happening with your system. So again, you can trend any of those features there, and you can definitely set your tolerances as well. So I just wanted to highlight a little bit on the graphs that you see here on your screen. We do provide in-plane and axial measurements for your MTF. So we give you a graphical representation of both of those. So we provided a synthetic line pair, and so we've applied the MTF calculation that we've received. We provide you your reference data set with your current image, and then you can get a visual representation of where your MTF lies for that series that you're viewing. Okay, so this is again just to provide some familiarity, because sometimes if you're just throwing a number of an MTF, it may not mean anything to you. So you can actually look and see how your MTF is performing. So moving on from this, we have provided a checklist for users for your daily QA. Now these are for customers who are not using a comprehensive QA tool that's monitoring their daily workload. This is for those users who are currently using like an external spreadsheet, or they're using some sort of a journal to document your QA processes. So you can actually customize this list by adding different tests. We do provide you the ability to print the actual checklist, so therapists or physicists can bring it into the room. We can export the information as a CSV file. Included checklist authorization, so that whoever is accepting or rejecting the QA is able to put that in here, and you can communicate with your physics department when there's a need for any sort of maintenance or if something needs to be checked. And again, this is just a tool to increase the value of the software itself. We do provide you with a 3D visualization tool. So this option here allows you to further examine the data set that you have, and you can scroll through and view the Phantom in 3D. We're also providing a line profile generator, so you can, if you want to view the Hounsfield units to see how uniform it is, you can drag a line across and it gives you the Hounsfield unit values. And we also provide more of a region of interest. If you want to move this box around, you can verify how uniform your Hounsfield units are there as well. So in addition to this, we have the ability to create reports. So you can create a template for different purposes. If you want to use it for communication with the physics department, if you want to use it for communication or just storing daily or weekly QA profiles, everything that was visible on this single series view has the ability to be printed into a report. So you can customize which metrics you want to display, and you can also customize which graphs are appearing. And I'll just quickly show you what that report looks like. It prints it out in a PDF, and as I said, like all your metrics are stated there. If it's out of tolerance, it'll show up in red, or if it's within, it'll be green for most of them. And then we just provide you those charts for your MTF as well. And again, just a communication tool that some users may find useful. And another item that we've added is the ability to input your daily shifts. Now, as I highlighted in the single series view, you can use a trending option where it automatically keeps track of your shifts, but there have been users that are comfortable with a spreadsheet that we were offering. And so that spreadsheet, people were manually inputting those daily shifts, but now we've included it within the software. So you can manually add those shifts in, or you can actually import a data set that includes all those shifts that were in an Excel spreadsheet. We've also added functionality where we can communicate with a PAC server. And this is for those users who like to keep all their DICOM data sets in a PAC server. So you can pull your Penta-Guide information from there if that's where you're doing it. Now, this is something that was grandfathered in from other software suites that we have. But if there happens to be users that want to communicate with their PACS system, you can definitely pull information from it. We just can't push information to it. And then the final tab here is our settings tab. And this is where you can select where your files are kept, where your backup is kept, your authentication levels here as well. And then the important one is for each machine, so each station, you can create as many as you like, depending on how many treatment units you have and the different profiles. You can actually set your tolerances. So we've provided some typically used tolerances for different testing parameters. But if you want to make them more generous, or if you want to make them tighter, you can definitely edit them here. And then that will be carried over into your display screen there. So overall, again, we've just added some features here to make the Penta-Guide more valuable, and we don't charge any extra for the software itself. Yeah, so that's about all I have in terms of the demonstration. And if you have any questions on this, you can ask in the question and answer period, or you can contact us through our website.
Thanks for the demonstration. That seems like a really useful tool, giving physicists helpful information about their systems. And I guess the added checklist and isocenter entry pages should make record keeping easier for those wishing to use them. So is the software also free for existing users?
Yes, yeah, the software is free for new and existing Penta-Guide users. So if you are an existing user, you can set up a user account at www.modusqa.com, or you can contact us through the website stating you would like to access the new Penta-Guide software. You just need to provide us with the serial number of your Penta-Guide, and we can quickly get you set up with an account and the software. So as a wrap up, I'd like to just highlight that the Penta-Guide now provides an even more valuable solution to perform machine targeting QA and to trend the health of your IGRT system. So by integrating the Penta-Guide Phantom into your daily routine, you can not only verify the alignment of your linac system, but you can obtain valuable image quality metrics, which saves physicists valuable time in eliminating the need to perform additional CAT fan scanning after hours. So, I would like to thank everyone for your time in attending today's session, and I look forward to answering any questions that you may have.
That's great. Thanks, Rocco. As he said, we're about to start the Q&A session, so if you've got any questions, now's the time to send them in. So, first of all, how do you calculate the MTF using the Penta-Guide? We use a CAT fan for this.
Yes, this is a complex one. I'll get into a bit of a physics discussion here. So the location of the surface of the sphere, relative to its centroid, is well known to a high degree of accuracy. So by plotting image pixel values against the radius of the sphere, you get what's called edge spread function, which is basically a graph that would have a sharp step up where the sphere, radius where it changes from air values to acrylic values. So from here, the process is essentially identical to using a slanted edge in projection X-rays. So the noise is smoothed out, and the derivative of the edge spread function is taken to give a line spread function. So this is equivalent to an impulse response function in signal processing. So by taking the Fourier transform of this, we get a frequency spectrum, which in this case is a graph of all the spatial frequencies that are present in the image. So this graph is the actual modulation transfer function, which is an illustration of how modulations or spatial frequencies are transferred through the system, which in this case is a CT scanner. So our algorithms calculate the MTF using two 30-degree cones in the in-plane and axial dimensions, providing a more robust representation of MTF. So misalignment of the image detector has a significant effect on the MTF, so trending this metric can be used as an ongoing method to ensure that your detector alignment remains stable. So if you require more information on this, you can definitely contact us through our website, and we can provide a journal article reference for highlights how this has been validated.
Great, thanks. Can the Penta-Guide be used on a ring-gantry system?
Yes, it can. So the Penta-Guide was designed for a traditional linac. However, it can be used with ring-gantry systems. So the Phantom can verify your 3D alignment using the sphere structures, and the projection images can verify your MV and KV alignment if the system has the capability to produce static projection images or the ability to perform MV cone beam CT. And the Penta-Guide software itself can process any cone beam CT as well as MV and KV 2D images.
Okay, do you have to use the software in order to use the Phantom?
No, you don't have to use the software with the Phantom. We highly recommend it based on the valuable information it provides. However, there are many departments that use the Phantom with their linac console tools, and then they keep track of their daily shifts using a spreadsheet.
Okay, and what is the measurement accuracy of the Phantom?
Well, we have a manufacturing tolerance of less than 0.25 millimeters, which is highly accurate considering most room lasers used for alignment are about 1 to 2 millimeters thick. And measurements with the Penta-Guide air spheres have been found to be very close to the accuracy of a BB-type Winston-Lutz device. but the added workflow efficiency makes it a very suitable device for daily QA.
Okay, next question. Where can we get the Workflow Guide 2.0?
Again, you can definitely contact us and we can have that sent out to you. So we have it in a PDF form. But if you have the actual software itself, there is a location where you can click on the question mark and it'll propagate that for you. So if you contact us through the website there's a way to communicate with our tech support and we can get that to you if you are a Penta-Guide customer or you plan to be a Penta-Guide customer.
Okay, thanks. Do centers use this for full Winston-Lutz tests?
Typically, you would want to use a Winston-Lutz for a little more detailed alignment and being able to make those adjustments. We do offer a proper Winston-Lutz wand where you can do very precise adjustments to your lasers. What you would do with this device is you can use it for Winston-Lutz type testing to alert you to actually do further investigation. So this is what you would use for a daily process. But we do have another dedicated wand that can actually perform the Winston-Lutz testing to a more detailed view of your alignment. So I just want to point out that the projection images that the Phantom is designed to handle are from a 0 degree or a 270 degree orientation. We don't have the ring and sphere locations for every degree angle.
Okay, is the software always opened on a separate computer and the image is imported manually, or can it be incorporated into the linac directly?
We haven't incorporated yet. There are things in the works where we're trying to get it incorporated into certain OEM equipment. But as it stands right now, you would have this open on a separate system, separate computer, and you would import the DICOM files into the software. Or you can, if you have a way to push all your information to a PAC server, you can communicate with that PAC server to pull that data into the software.
Okay, great. Next question. Does the system support megavoltage images? And is the difference between kilovoltage and megavoltage isocenter calculated by the system?
No, so the idea behind it is it would be the same. That is the whole idea that you can perform images with your IGRT system, so your KV components, and then you would perform the same setup, so the same alignment test by taking MV images. So you can definitely use both.
Okay, great, thank you. Right, that's all of the questions that we've had sent in. So thanks to all the audience who asked questions. If anyone would like to watch the webinar again or recommend it to a colleague, it'll soon be available on Physics World. Finally, thanks again, Rocco, for a great presentation. Thanks to everyone who's joined us today. And this webinar is now over.
Thanks, everyone.